Okay, so this is the extended question, question number 3, and I have this square root, and the square root's been moved to the left 1 and down 1 to have its endpoint at -1, -1, and it goes through the origin. Okay, so that graph is using numbers to find out. Okay, the transformation that will take xy to x plus c, y plus d, maps the graph of this graph to the graph of square root of x. And the square root of x looks like that graph. So in mapping notation on our grid is on the far left, and it's as you see it. So if that says plus c, that means you've moved c to the right. So if I'm moving this point to that point, I've moved to the right 1 and up 1. Therefore, c has to be 1 and d has to be 1. So therefore, 1 and 1 are the answers. The graph of f is to undergo a dilation from the y-axis so that the endpoint of the image is -2, -1. This is the graph of f. This is my graph of f. So f is going from -1, -1, so the endpoint, to -2, -1. And there's a dilation. So the dilation must be a factor of 2 from the x-axis, the y-axis. And I'm multiplying the x value by a factor of 2. -1 became -2. -1 stayed -1. So since the y value hasn't changed, b has to equal 1. And since the x value has gone from -1 to -2, a must equal 2. You need to get them both right to get it correct. Now, we have this square root graph, positive square root graph, that has been moved to the left 1 and down 1 because of the +1, -1. Over the page, this question uses the same square root graph, except it's been moved to the left n and down n. So it's the same question as what we had on the previous page, except 1 has been replaced with n. On the previous page we had the square root of x plus 1 minus 1. Therefore we were at -1, -1. But now we have -n, -n. So find the values of n for which the graph is always positive. So when n equaled 1, then the graph down here wasn't always positive. Therefore, n can't equal 1. If n equaled 0, the graph would be here at 0, 0. So we're wanting n to be -1 or -2 or -3 or -4. We want n to be less than 0 if the graph is always bigger than the x-axis. Find the rule of the inverse and the domain of the inverse. Well, the domain of the inverse will equal the range of the function, and the range of the function should go from here to infinity. So that's -n inclusive up to infinity. And to come up with the rule, I've entered this into my calculator and gone solve for y, and it came up with that. Some calculators might give x plus n squared minus n, and that's also perfectly correct. And find the coordinates where the point of the intersections intersect. Again, using the calculator, I come up with -n and 1 minus n. So what we're saying is I've got my square root, and I have my inverse. I'm going to have a problem with drawing. This answer that I know is -n, the end point, and I'll have this other point. Keep in mind we also have the line of y equals x that goes through there, so you could set this equal to x. You could set h equal to x, or you could set h equal to its inverse. All of them will give the same two answers. Okay, so that's homework worksheet number 2.